Okay, welcome students. This is your Unit 1 Day 2 homework prep. You can see here that we're on pages 4 and 5 of your Exponent notebook. What I would do is I would advise you just to pause the video and copy down the structure that I have here. Copy down the boxes and all the shapes and so forth on page 4 and 5. Also notice that the learning objective here at the top, this guy actually will span across both pages. So go ahead and just draw a box that goes from one side to the other. And then what we're going to do is we're going to fill in values here in a moment. So pause the video, take about 10 or 15, I'll say maybe a couple minutes or so, and go ahead and copy this down, and then we'll begin to fill it in a moment. Okay, let's start to fill in our values here. All right, you already have written down at the top, page 4 and 5. You also have product of powers on page 4 and quotient of powers on page 5. Let's copy down our learning objective. The learning objective says this, copy this down. I can simplify exponential expressions by multiplying and dividing powers. Now remember, at any point in time, if I'm going too fast, you guys can pause the video and have me repeat it, or at least slow me down. Okay, so let's concentrate over here on page 4 on the product of powers. And let's do a little bit of vocab. Okay, so the vocab word here is the word product. So you gotta remember what that word means. Remember that a product is just the answer to a multiplication problem. So if you guys put down multiplication answer. Next, let's talk about an example. For the product of powers rule, you can see here I have 2 squared times 2 to the third, those 2 powers. I also want you to notice that those 2 powers have the same base. They're on the bottom, I have a 2. Okay, well, 2 squared is just 2 times 2. 2 to the third is just 2 times 2 times 2. So since all those 2's are connected through multiplication, it's all one big multiplication clump, that basically means that we're multiplying 2 times itself 1, 2, 3, 4, 5 times, or 2 to the 5th. Well, some of you guys are going to notice this right away. The trick or the rule here is just to add the exponents. 2 to the second times 2 to the third is 2 to the 2 plus 3, or 2 to the 5th. And that's the rule I want you to copy down. When you multiply 2 powers that have the same base, then you add the exponents. On the bottom, I have a generic little formula there. Notice that x to the a times x to the b, they both share the same base, x. And then the a and the b just get added, x to the a plus b. Remember that you can pause the video anytime if I'm going too fast. Let's look at a couple of examples. Look at these 4. Here I have, on number 1, I have 5 to the second times 5 to the 4th. They both share the same base, 5. We know that 5 to the second is just 5 times 5. We know that 5 to the 4th is 5 times 5 times 5 times 5. Okay? Well, if you look at that visually, you can see that that's 5 multiplied times itself 6 times. You do not have to do this expansion method if you don't want to. You go to look at that problem and say, okay, they have the same base, therefore I can add the exponent. This is going to be 5 to the 6th. Okay? Look at number 2. Number 2 has 4 to the second times 4 to the negative third times 4 to the 4th. Now there's 3 powers here, but that's okay. They all have the same base, which means we can add their exponents. So even though there's a negative 3 there, it's not going to affect the rule. It's still going to work the same way. So 2 plus negative 3 is negative 1. Negative 1 plus 4 is 3. This one will be 4 to the third. Now, I can already hear some questions out there. People say, what if I actually figured out what 4 to the third was? What if I did 4 times 4 times 4 and got 64? Would that be an acceptable answer? And the answer is yes. I would accept either one of those 2 answers correctly. Whenever you're dealing with an integer base, if you want to change that into a numerical value, that's fine. But you can leave it as 4 to the third. Because what I'm really trying to test here is to see if you guys can use the rule correctly. Okay? Now notice at the bottom 2, here we have variables for our base. So we're not going to be able to figure out what these integer values are. So here we're just going to use the rule. We have a to the 4th times b to the 5th times a to the second times b to the negative third. So here we have a situation where we have 2 different kinds of bases. Since all these powers are connected by multiplication, we can use the commutative rule, which basically just means that we can rearrange it any order that we want. So I can say, okay, a to the 4th and a to the second are going to go together. And then b to the 5th and b to the negative 3 are going to go together. Well, I'll just add the two a's together, so 4 plus 2, that's a to the 6. And then I'll add the b's together, 5 plus a negative 3, a little tug of war there, and the 5's going to win by 2. So you end up with a to the 6 squared. Okay, last little box here. Y squared times y to the 0 times y to the negative 4. Okay, well, we discussed on Wednesday and Thursday that anything to the 0th power is just 1. So I know that I can look over here at this guy and just say, I'm going to go ahead and make this one a 1. Okay? So really all I had to deal with here is just y to the 2nd and y to the negative 4. When I add those two exponents together, I get y to the negative 2. This is a correct value. It's a perfectly fine step towards the right answer, but it's not the final answer. And the reason why is because it has a negative exponent. So you'll remember my cheesy story. This guy's in the numerator up here at the top. It has a ticket to ride the elevator. It's going to ride it down to the bottom floor, and when it does, it's going to end up with a positive exponent. So 1 over y squared is our answer. Okay? Earlier at the beginning of the video, you guys copied down the rectangle and square down here. So let's put in some values that we can actually use rectangle and square. Let's say that I give you this width is x to the 3rd, and this length is x to the 4th. And I want you guys to recall, if I'm asking you guys to find the area of a rectangle, remember, that's just length times width. So we're going to multiply these two powers together. Which of course is the powers. X to the 3rd times x to the 4th will just mean that I'm going to add the 3 and the 4 together. So the area should be x to the 7th. Not too bad, right? All right, let's take a look at a square. Let's say that I tell you that one of the lengths of the square is x to the 5th. Okay, well, a couple of things here before we begin. Remember that a square is just a special rectangle. It's just a rectangle in which all the sides are the same. So we're still going to use length times width because before, it's just that the length and width are going to be the same. So if I tell you that this side over here is x to the 5th, you also know that this side over here is x to the 5th. Well, when we do our product of powers, our length times width here, we just add up our exponents. Remember, that's not going to be 25th. It's going to be x to the 5 plus 5. Yeah. Okay. Let's go over to the right side. Page number 5, quotient of powers. Let's copy down some quick vocab. What is a quotient? Well, most of you will remember that a quotient is just the answer to a division problem. So a division answer. Let's talk about, it should say the power of quotients rule. Oops, Mr. Goldberg messed up. That word right there should be quotients. Make that change. Here I have a fraction. I have 2 to the 3rd over 2 to the 2nd. Well, in this fraction, on the top, I'm going to have 2 times 2 times 2, or 2 cubed. On the bottom, I'm going to have 2 squared, or 2 times 2. Well, you guys will remember through division earlier in your mathematics careers here that you can begin to cancel some of these values out. So, for instance, 2 divided by 2, those two guys just become a 1. Right? 2 divided by 2. And then you have another pair of 2s that can cancel out here. That's another 1. So you're left over with just 1, 2 on the top, or 1 times 1 times 2, which is just 2 to the 1st power. Now, on the left side, we added the exponents. Over here, I bet you guys are already guessing, we're going to subtract the exponents. Let's copy these down. When you divide two powers that have the same base, then you subtract the exponents. And you can look at the general formula there. I have x to the a over x to the b. Notice that they have the same base, x, and that allows us to subtract the a and the b. Pause the video if you need to get that down, and let's take a look at a few examples. Okay. The first example has 5 to the 4th over 5 to the 2nd. Okay, well, we know from our example up there, what that basically means is that we have 5 times 5 times 5 times 5 over 5 squared. And we know that we can go through with our division and say, okay, those cancel out, those cancel out. And we end up with 1 times 1 times 5 times 5. Now, you can write 25 down as your final answer. That's perfectly acceptable. But I'm going to go ahead and use the rule. Since these guys have the same base, I can subtract the 4 and the 2, and I can just get 5 squared. In other words, I have 2 more 5s looked up over top. Okay? Take a look at number 2. In the numerator, I have 4 squared times 4 to the 4th over 4 to the 3rd. Okay, so the ones on the top are a product. I'm going to add those exponents. And then I've got the division with the 4/3 at the bottom. I'm going to end up subtracting away that 3. So 2 plus 4 is 6. Then I'm going to subtract the 3. So 6 minus 3 is going to give me 4/3. Okay? And yes, of course, you could write this as 64. If you take a sneak peek over here to the problem on the left, you'll notice that these are essentially the same problem. Okay? All right, take a look at number 3. Here I have a to the 4th times b to the 3rd on top, and then I have a times b to the 5th on the bottom. Okay, well, you know that the a's are going to go together, and you know that the b's are going to go together so they can interact. Also, one thing we're going to forget is this little a right here, even though it doesn't have an exponent written for it, we know that that's a to the 1st. Okay, so don't forget that. So as we begin to write our final answer here, I'm going to do the 4 minus 1 for the a's. That gives me a to the 3rd. Now notice there's 3 more a's on top, so a to the 3rd ends up going on in the numerator. Okay, take a look at the b's. They're a little bit different. I got b to the 3rd on the top, and I got b to the 5th on the bottom. If you did the subtraction, 3 minus 5, 5 will win that tug of war, and you'd end up with a negative 2, b to the negative 2. And then eventually you had to take that guy and have him ride the elevator, and you ended up on the bottom. Okay. So let's stop thinking of it that way. Let's just think about, where do we have more b's? Well, obviously we have more b's on the bottom. How many more b's do we have? We have 2 on the bottom. So if you want to skip that negative exponent step, you can just say, I know I'm going to have 2 more b's left over on the bottom. So a to the 3rd over b squared. Okay, so take a look at number 4 here. Y to the 3rd times y to the 0 on top, and then y to the 3rd times y to the 1st on the bottom. Okay. The y to the 0th on top, I know that that guy's going to turn into a 1. So I can basically ignore it for this division problem. On the bottom, I'm going to have y to the 3rd times y to the 1st. I'm going to get to add those exponents. Okay, so what this guy's going to look like is y to the 3rd over y to the 4th. Okay, now we need to begin to think about, where do I have more y's? Well, we have more y's in the bottom. How many more? I have 1 more y on the bottom. So I can write this as 1 over y. Some students are going to ask, is it okay if I write this little y to the 1st right here, if I can add that exponent? You bet. There's nothing wrong with that. It's just you don't need it. Okay? Let's do a couple of geometric application problems here. For your rectangle, let's say that I give you guys an area of x to the 10th. And then I give you that one of your sides, let's say this width over here is x squared. So it's a little bit different than the ones that we did over here on the left. In other words, we got to find the missing side. So what's really going on here is that length times width problem. We say we have x squared times x to the something is going to equal x to the 10th. Okay. Well, if you remember your product rule here, you know that 2 plus something is going to equal 10. Well, that something has to be a. You're going to end up with the missing side of x to the a. Why does that work? Because 2 plus a equals 10. Okay. Let's go to the square. Let's say that I give you that your area is a to the 16th. Okay. Well, you know that a square, the sides are going to be the same. So these two sides are the same. So what we have here is, we have length times width, we have x, sorry, not x, we have a to something times a to the something equals a to the 16th. And since it's a square, we know that those two blanks, those somethings, have to be the same. Our product rule states that those two numbers will add together to give you 16. So I know your instinct here is going to tell you 4, because 4 times 4 is 16. That's not how this works. Remember, when you do the product of powers of two exponents, you add them together. So we need something that's going to add together to be 16. 8 plus 8 will work. So this guy down here, the missing link will be a d8. Okay. Your job is to have this completed, brought into class either Friday or Tuesday, depending on whether you're A or B day. Also be able to ask some questions. Tell me where you're at. Do you feel very comfortable with this? Or you'd like me maybe to go over a couple things and explain things more fully? Or you can flat out tell me I am completely lost and you start at the beginning. But it'll allow me to cater my instruction to what you guys need. All right, thank you very much.